For most of human history, we thought we were the center of everything. Then Copernicus showed up in the 1500s and basically said, yeah, no, we go around the sun. Then we found out the sun itself is just one of billions of stars inside a massive galaxy we call the Milky Way. And in 1924, Edwin Hubble dropped another bombshell. Andromeda isn't part of our galaxy at all. It's an entirely separate galaxy, sitting way beyond the Milky Way. Every single time, our place in the universe got a little smaller, a little more humbling. But in 1995, one person's risky decision was about to shrink it even further, in the most jaw-dropping way imaginable. When the Hubble Space Telescope launched in 1990, nobody noticed a 2.2 micron flaw in its mirror during production. That tiny imperfection meant incoming light couldn't focus properly, and Hubble's first images came back blurry. The most expensive telescope ever built had been sent into space. Broken. NASA spent over $600 million on a repair mission in 1993 to fix it. And the pressure that followed was immense. Hubble couldn't afford another embarrassment. Every observation had to count. Every hour had to justify itself. So when Hubble's director, Robert Williams, announced he wanted to point the telescope at a patch of sky that looked completely empty. No known galaxies, no nebulae, nothing. People thought he'd lost his mind. We're talking about a region right next to Ursa Major. Even through the most powerful ground-based telescopes, it was pure darkness. And the area itself? Imagine holding a pin up to the sky. The patch Williams wanted to observe was roughly the size of that pinhead. But Williams had discretionary observation time, a privilege that came with his directorship. And he used it, despite the pushback. He went for it. On December 18, 1995, Hubble locked onto that tiny dark patch of sky. For 10 straight days, it made 342 separate exposures, chasing every last photon that dared to leak out of that darkness. When the data came back, everyone went silent. That empty patch of sky wasn't empty at all. It was full of light. Not stars, galaxies. Around 3,000 of them, each containing billions of stars and likely billions of planets, crammed into a single image. This photograph, the Hubble Deep Field, became one of the most important images in the history of astronomy. But here's where it gets truly mind-bending. The Deep Field covered about 2.6 arc-minutes of sky, roughly 1/24 millionth of the entire sky. And in just that sliver, there were approximately 3,000 galaxies. Scaling that up, astronomers estimated there had to be at least 70 billion galaxies in the observable universe. And then there's the time machine part. Light travels at roughly 300,000 kilometers per second. Fast, yes, but not fast enough when you're dealing with cosmic distances. Light from galaxies millions of light years away takes millions of years to reach us. So when we look at distant galaxies, we're not seeing them as they are. We're seeing them as they were. Some of the light in the Hubble Deep Field had been traveling for over 12 billion years. Since the universe is about 13.8 billion years old, we were essentially watching galaxies when the universe was still in its infancy. Just a few 100 million years after the Big Bang. Those reddish galaxies in the image? That's not their actual color. Their light stretched out over billions of years of cosmic expansion before reaching us, a phenomenon called redshift. The redder the galaxy, the older and more distant it is. When that light first set off on its journey, our sun didn't even exist yet. We were, in a very real sense, looking back before our own birth. Astronomers could study that single image to understand how galaxies formed, how they evolved, and what the early universe actually looked like. It was science fiction made real. Naturally, they wanted to do it again. In 1998, Hubble turned toward an equally dark patch in the southern sky. The Hubble Deep Field South confirmed what the first image had shown. No matter where you look, the universe is packed with galaxies. Every direction, every corner. Nothing is truly empty. These two images also had a very satisfying side effect. They completely rehabilitated Hubble's reputation. The telescope, once mocked as a billion-dollar mistake, had just produced some of the most scientifically significant photographs in history. That momentum led to 4 additional servicing missions to upgrade Hubble with newer, more powerful equipment. The most significant of these came in 2002 during the STS-109 mission, when Hubble received the Advanced Camera for Surveys, ACS, twice the field of view and significantly more light sensitivity than its predecessor. Hubble could now see fainter, more distant galaxies than ever before. In 2004, Hubble pointed at a region in the constellation Fornax, again pitch black to ground telescopes, and stared at it for 11 days with over 800 exposures. The result was the Hubble Ultra Deep Field, around 10,000 galaxies in a single frame. Some of that light had left its source just 800 million years after the Big Bang, reaching Hubble's mirrors 13 billion years later. Then in 2012, astronomers combined 23 days of Hubble observations with archival data from 2002, 2003, and 2009 to create the Hubble Extreme Deep Field, covering just 1/30 millionth of the sky, yet revealing around 5,500 galaxies, including some so faint they emit just 1/10 billionth of the light the human eye can detect. We were seeing galaxies from 13.2 billion years ago, the universe's baby photos. For years, the Extreme Deep Field held the title of the deepest image of the universe. Then James Webb showed up. Launched in December 2021, the James Webb Space Telescope sent back its first images on July 12, 2022. And unlike Hubble's troubled debut, Webb delivered beyond all expectations right out of the gate. Images of the Carina Nebula, Stephan's Quintet, and the Southern Ring Nebula were both visually stunning and scientifically rich. But the image that truly made history was Webb's photo of galaxy cluster SMACS 0723, located about 4 billion light-years away in the constellation Volans. Hubble had photographed this region before, but Hubble was designed primarily for visible and near-infrared light. It couldn't see galaxies whose light had shifted far into the infrared. Webb was built specifically for infrared observation, so it revealed far more clearly. What really sets the SMACS image apart is that Webb didn't just stare into empty space, it used the galaxy cluster itself as a natural telescope. If you look carefully at the image, you'll see galaxies stretched into arcs around the center. That's gravitational lensing. SMACS 0723 is so massive that it bends the light from galaxies behind it, magnifying them like a cosmic zoom lens. Those warped, stretched shapes are galaxies that would otherwise be completely invisible. Too faint and too distant. Thanks to this effect, Webb captured details from 13.1 billion years ago, just 700 million years after the Big Bang. And here's the kicker. Hubble needed weeks to achieve its deepest images. Webb got this shot in just 12.5 hours. Webb then set its sights on the same region as the Hubble Ultra Deep Field and surrounding areas. In 2023, it photographed the Good South Field and captured over 45,000 galaxies in a single image. One of them stood out immediately. JWST Z14 had a redshift value of 14.18, corresponding to just 300 million years after the Big Bang. It's one of the earliest galaxies ever detected. But what made it truly strange was its size and brightness, about 1,600 light-years across, roughly 60 times smaller than the Milky Way, yet extraordinarily luminous. Spectroscopic analysis detected ionized hydrogen and oxygen, which shouldn't be there. Producing oxygen requires multiple generations of stars to live and die first. Having that much oxygen that early in the universe challenges our existing models of how and when the first heavy elements formed. Webb's JADES data suggests that the first stars and galaxies formed much faster than we thought. Scientists are still updating their models of the early universe to account for what Webb keeps finding. When Robert Williams pointed Hubble at nothing in 1995, Plenty of people called it a waste of time. They were spectacularly wrong. What began as one director's risky bet has grown into a decades-long project that keeps rewriting our understanding of the cosmos. Deep field images have shown us that no part of the sky is truly empty, that every dark patch hides thousands of galaxies, and that looking deep into space means looking back in time, all the way to the universe's earliest moments. These aren't just photographs, they're windows into where everything came from. See you in the next one.